This is the part 6 of the video series on properties of perfect squares or square numbers. The video links to the tutorials on part 1, 2, 3, 4 and 5 are given in the description box below. Please watch them if you haven't watched them already. Now we have 3 tables here and each of these tables has 2 columns. The first column in each table has number and the second column in each table has the perfect squares of these numbers. So the perfect square of 1 is 1, of 2 is 4, of 3 is 9, so on and so forth. Of 11 is 121, of 15 is 225, so on and so forth. Now, if you look at these 3 numbers, that is 5, 15 and 25, right? So what's common in these 3 numbers? They all end in 5. That is, they have 5 at their units places. Now, if you look at their perfect squares or square numbers, the perfect square or square numbers of 5 ends in 5, that is, it has 5 at its units place. The perfect square or square number of 15 is 225, that is, it ends in 5, that is, it has 5 at its units place. The perfect square or square number of 25 is 625, that is, it ends in 5, that is, it has 5 at its units place. Now, if you look at in this column, and this column, that is the perfect squares, no other number ends in 5 except these 3 numbers, right? And what's common? They are perfect squares or square numbers of those numbers that end in 5. So what's the property? The property is that if, let's say, this is a perfect square given to you, let's say it's any number and it ends in 5. Okay, it ends in 5 and you have 4 options. Option A is that it is a perfect square of number that ends in 2. It is a perfect square of a number that ends in 6. It's a perfect square of a number that ends in 0. It's a perfect square of a number that ends in, let's say, 5, right? So it's an objective type question and it's given to you that this is a perfect square and it ends in 5. So you have to tell of which number from these 4 options this is a perfect square of which number, right? So instantly you have to choose this one, right? Instantly. If there is only one option that ends in 5, so you have to reject all these. But imagine that if C was not, this option C was not, it doesn't end with 0, but it ends in 5 also, that this number also ends in 5. In that case, you have to select C and D, reject these 2, and then you'll have to find that which is that number whose perfect square is that number, because now both these 2 numbers end in 5, right? So this number can also be the number whose perfect square is this number, and also this number can also be true. So you'll have to find in that case.